This is the Algebra 2-3 Common Core Quadratics unit, and I'm going to review problems 20 and 21 on how to graph quadratics. So we're given an equation that says y equals x squared plus 6x plus 4. And the first thing we need to do is get that in vertex form. Vertex form says that y equals a times the quantity x minus h squared plus k. So the first thing we see is that we need to complete the square because we need a binomial squared. And then we'll also have some number here on the end representing our k. So from this equation, I'm going to subtract the 4 first. That allows me to have the x squared and the x by themselves. I look at my b term, which is 6, and we're going to divide that in half. Half of a positive 6 is 3. We square the 3 and we get 9. This is the completing the square method. We have to make sure, though, we put a 9 on both sides. Remember, in math, we're very fair. If we put a positive 9 on one side, we have to put a positive 9 on the other. That accomplished us getting y plus 5 equals. This now factors. If I asked you to factor, you'd say x plus 3 times x plus 3, and we're going to write that as x plus 3 quantity squared. Then we would move the 5 over. So I have y equals x plus 3 quantity squared minus 5 because I subtracted. That is the first step in graphing. You want to get it in what we call vertex form. And now we have it in vertex form. The next thing, you want to look at what actually is the vertex. This is the point in our parabola where it changes directions. So we look at our h value, and you always switch the sign on the h value. So h is whatever's with k in parentheses, and we're going to make it a negative 3. K, you keep the sign. So we make that a negative 5 because it's a negative 5 in our equation. So we change the h sign, keep the k. That also gives us the axis, which is the line of symmetry. So if I go to my graph and I plot negative 3, negative 5, there's my vertex. And we know that a parabola is going to be a curve, a U-shaped curve going up or down. And the axis is the line that goes right through the center of the graph, where I can fold it in half and it would be equal on the left and the right. X equals negative 3. It's an x equals equation because it's vertical. It's negative 3 because it's cutting through the x at negative 3. It's always whatever the h value is. The next thing we want to look at is our distance. Distance is always defined as 1 over 4a when we're looking at parabolas. So we go to our equation. Whatever's in front of parentheses is your a value. In this case, it's 1. So my distance is 1 over 4 times 1, which is 1/4. The distance is going to do two things. It's going to give us the focus and the directrix. For the focus, you add the distance. So if the distance is 1/4, we add it to the vertex. So that's graphically what it looks like. Numerically, we use the vertex, which is negative 3, negative 5, and on that negative 5, we add a 4th. We would never leave it like that. We do want to simplify. So it's negative 3, negative 4, and 3/4. That's the point we've already graphed on our 3/4. We've already graphed it on our coordinate plane. The directrix is the same distance away, except it's in the opposite direction. So we literally write the negative 5, but we're doing a minus 4 this time. We write the same thing, we change the sign. The directrix is a line that says y equals. So y equals negative 5 and 1/4. And that falls off the coordinate plane I gave you just a little bit, but it's fine. We're going to do the best we can. And there's our directrix. So we have all the supporting parts of the curve just we don't have the curve yet. The last part's the shifts, trying to decide, how wide, how skinny this curve is. To do the shifts, we follow 2 steps. Over 1, up 1 squared times a. Over 2, up 2 squared times a. And like I said earlier, a is 1 coming from right here. And you need to plug the a in. So we use the a for the distance. We use the a for the shifts. So from the vertex, we go over 1, up 1. Because 1 squared times 1 is 1. So over 1, up 1. Like I said before, it's symmetrical. So you also go back 1, up 1. So now I'm given 2 points. Then I'm going to go over 2, up 4. Because 2 squared is 4 and 1 is a. So over 2, up 4. And because we know it's symmetrical, I can go both left and right. Your curve comes from the vertex, not the focus, so make sure that your focus is not connected. You can even put a little F next to the focus so you remember what it is. And those are all the steps to graphing the quadratic equation for problem number 20. We're going to move on. We're going to look at 21. 21 is just a little quicker because it's already in vertex form. It's already in vertex form for you. So the first thing we're going to do is write that vertex. We use our H. Remember, we changed the sign. And we keep the sign on the outside. So we have 2, 6. And what I suggest you do right now is maybe pause the video and try and do as much of it as you can before watching the rest. See what you can do on your own. The axis, is x equals 2. It's whatever your h value was. So we have a vertical line at x equals 2, just like that. Next step is our distance, which is 1 over 4 times a. Now, this one's a little bit different because a is not 1. A is a negative 1/2. So that's very important here. A is a negative 1/2. So we plug that in and we get 1 over negative 2. So our distance is negative 1/2. Now, because a is negative, you need to assume it's going down. A is negative. That means that my quadratic graph is going downward. So my distance is negative 1/2. For my focus, I'm going to take my vertex and I'm adding the negative 1/2, which makes it 2. And 2 and then 5.5. So on my graph, 2, 5.5. It's kind of small. Do your best you can to graph it there. For the directrix, you do the same thing except it's y equals, and we're going to subtract the negative 1/2. So we get y equals 6.5. Now, the directrix, remember, is a line, not a point. So there's my directrix. So we have everything on the graph we need, and now we're going to do our shifts. Shifts are over 1. In this case, we know it's going down, so we're going to go down 1 squared times a. Now, a in this case is negative 1/2, not from the distance. It's really important to know that the negative 1/2 is coming from the equation up here. So I'm going 1 squared times negative 1/2. Over 1, down 1/2. Then I'm going to go over 2, down 2 squared times negative 1/2. Multiply that together, we get negative 2. So we're going over 2, down 2. Over 2, down 2. And each time we go back to the vertex to plot our points. So we see that our parabola is going down. just like that.